All right, so ladies and gentlemen, today, section 10.2, we are talking about something called an arc and how it relates to something called a central angle. So, first off, definitions. Central angle is kind of what you think. It's an angle formed in the center of the circle. So it's on our vocab sheet. We're just going to fill this out a little bit. Central angle is an angle whose vertex, right, the vertex is at the center of the circle. So right here, this is a central angle, right? Central angle, angle ACB, right? This is a central angle because it's formed by the center. Okay? We'll learn other ones that are not in a bit. And then an arc is formed by part of these circles. The arc is the outside. It's like some fraction of the entire circle. We call it a minor arc. So it's the part of the circle if it's less than 180 degrees, okay? like this. This would be a minor arc. We would call it a major arc if it's greater than 180 degrees. Okay? So this would be a major arc. Okay? So again, an arc is just part of the circle. Less than 180 minor, greater than 180 major, and you might have heard this term before. If it's exactly 180, we call it a semicircle. Okay, so anything less than 180 degrees, it's minor. Anything greater than 180 degrees, it's major. Anything equal to 180 degrees, so if it's exactly halfway, we say that that is semicircle. Okay. And then finally, what do we call congruent circles? Congruent circles. Right? Because how do you compare circles as opposed to triangles? Well, circles are all the same shape, so you don't have to worry about the shape part. We just have to worry about size. How do you measure the size of a circle? Well, if you think about it, they would be the same if they have the same radius, right? Because the radius determines the size. The radius determines the size. So that's circles. Now, how about arcs? Two arcs are congruent, so parts of a circle, if they have the same measure and they are arcs of the same circle or congruent circles. Okay, so we'll come back to this problem, but that's the idea. So we'll come back to here and to here after a little bit more of exploration. So I mentioned something called a central angle and a minor arc, right? This is the angle, this is the arc. How do they relate to each other? And so what I'd like us to do is go to the link for today, the GeoGebra link, which is right here. You can just click on it. And so what we see here is a little circle. And so what I want you to notice is that right now the radius of this circle is 5. This is the central angle measure, 50 degrees. This is the arc measure, 50 degrees, right? This red part is the arc, right? It's part of the circle. This is the central angle. So if you take this and you move it, keep an eye. Notice that as the central angle changes, the arc also changes, the measure, the number of degrees. Notice that they are exactly the same. So first thing to notice, the central angle measure is exactly the same as the arc measure. So we can write that down. The central angle measure is exactly the same as the arc measure. Okay, central angle, this is always equal to the arc. Okay, so 50 degrees, if that was true, we'd say the measure, and if you see this little kind of umbrella, rainbow type of thing, that's the measure. This is an arc. So the measure of arc AB, if this is 50 degrees, is also 50 degrees. Okay, so that's also in your theorem sheet, so let's just write that down to remember. So turning to page 2 really briefly, okay, your theorem sheet. Measuring arcs, okay? The measure of an arc is equal to its central angle. So again, if this is 50 degrees, this angle here, the central angle, then this arc measure, this piece of the circle, would also be 50, 50, 50. Okay? All right. And then we also have something called, just to finish it up, the arc addition postulate. Just like segment addition, angle addition, it just says if you want to find the measure of arc ABC, by the way, if it's 3 letters, you just kind of trace it around. So ABC would be ABC, this arc here. Now if I say AB with only 2 letters, measure of AB, does that mean AB this way or AB that way? If I just say two letters and nothing else, you can assume it is the minor arc. Okay, so if I say AB, I don't mean this. I said that ABC this equals this guy, AB, plus, again, if I say two letters, I'm assuming it's the minor arc. So I don't, BC, I'm not meaning this guy, I'm meaning this guy. Okay, so just like, with segment addition, angle addition, we can just say that this whole big arc ABC is equal to this minor arc AB and this minor arc BC, right? Arc addition postulate, just like angle addition, segment addition, okay? So the final thing I wanted to see with this GeoGebra was that it's not just the angles though. If you look at this number here, this represents the size of the arc, because you can imagine we have different circles, right? We measure the size of the circle by the radius. So watch, as I shrink this circle, and you can go along too if you want, as I shrink this, notice this red number here, which is the actual length of this arc, shrinking, 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 right? So the degree stays the same, right? So if I move it to, like, I don't know, here, half of this circle, right? So this is 180, this is 180, right? They're both 180. But no, it would make sense, right? As the circle shrinks, the actual length of this semicircle is shrinking down, right? Or if I grow it, it's getting bigger and bigger and bigger again. So we can't just call these arcs congruent if it's 180 and 180. It has to also be from the same measure of the radius, right? It has to be an equal size circle. So you have to check to make sure that the radius is the same. Otherwise, you're not comparing apples to apples, right? Even if they're both 180, the size of the circle has to be the same, because otherwise, this changes as you obviously grow or shrink it. Okay, so congruent circles have the same radius. Congruent arcs, as I just said, have to be the same measures, like 180, 180, but they also have to be the same size circle, right? Congruent circles, or from the same circle itself. Okay, so to finish that, to say whether these are congruent or not. So red arc, sorry, this should be red here, and this should be red here. Okay, are these congruent? Right. Are these congruent? Well, since this is 80, remember this is a central angle. This is a central angle. This would also be 80. This would also be 80. Okay, so they have the same measure, right? They're the same degrees. Is it from the same circle, or at least congruent circles? Because otherwise, again, you're not comparing apples to apples. That is. So here, these are the same. These are congruent. So I can say yes. Okay. Here, look at this one. Let me mark this to be red. Red. Are these congruent? So first off, let's look at the measure. If this is 90 degrees, right, this central angle, that means this is 90 degrees, right? This measure, it's 1/4 of a circle. This guy here is also 90 degrees. So they are the same measure, the same number of degrees. However, this red arc is clearly smaller than this arc because it fails the second test, right? This red arc is from the small circle. This red arc is from the big circle. So we can say no, right? RS, this arc RS, and TU are not from congruent circles, right? They're not 90 degrees. They're not 1/4 of the same size, right? We saw how, again, when I grow and shrink, so let's say they're both, like I've got 90 and 90, right? Let's say I had 90 degrees here, 90 degrees there, right? But as I grow and shrink it, the actual size of this guy is going to change, right? So you can't have different size circles like that, okay? And then finally, this guy right here and this guy right here, okay? So let's look at the measure first. This is 95 degrees. Again, this is a central angle. This is also 95, right? This is 95. This is also 95. So again, we passed this test. They have the same measure. Are they from the same circle? No. However, again, you don't have to be from the same circle. You can also be from congruent circles. And since these have the same radius, we know they're exactly the same size. We don't know how big that is, but we know it's the same size. So we can say yes, right? They have the same measure. They have the same measure, 95 degrees. And they are from congruent circles. So whereas this one, they were different size, this one we know they're the exact same size. So we can call these two arcs congruent. Tick, 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 tick. Okay, so that's it for the vocab and theorems. Let's go ahead and look at our work for today. Okay, so now let's go ahead and take a look at our notes for the day. Finding arc measure. Again, an arc is just a piece of the circle. Right? It could be any piece on the outside. Right? The entire circle would be 360 degrees. Semicircle would be 180. We've got minor, major arcs. So yes, this is going to be page 5. Okay, so we already did this GeoGebra thing, so let's find the measure of each arc. And remember, the arc is always the same measure as the central angle. So we look here, arc, RS, this little rainbow thing. Again, when you see 2 letters, you can assume it's a minor arc. 2 letters. So RS is a minor arc, so I look over here. It's that. So that would be equal to the central angle. So this is 110, this is 110 degrees as well, right? RS is a minor arc. So the measure of arc RS is the same. It's 110. Okay. RTS. So when you see 3 letters, you trace it around as you say it. So RTS would be like that. So that picture kind of helps us to see, how would I find that? How would I find that? Think about, how would you find that measure? Hopefully we see RTS, we can see that this whole thing equals 360 degrees. So if I just take 360 degrees and I subtract out this, right, that's due to the arc addition postulate, right? We say that this little arc plus this little arc equals the whole arc, which in our case is 360. So 360 minus 10 is 250 degrees, right? RTS is a major arc. So the measure is 250 degrees. RST. What would RST be? From here to here. So you have to look carefully, but what you notice is that since this chord goes through the center, it is dividing it in half. So RST, so RT is a diameter, right? So the arc that intercepts the diameter is a semicircle, and so therefore the measure of arc RST must be 180 degrees. Okay. Why don't you try? Pause the video, go ahead and fill these out. Actually, no, just skip these. I'm trying to finish as soon as possible. Why don't you go ahead and just do this one? So find the measure of these arcs, identify each one as major arc, minor, or semi, and find the measure. Go ahead and pause the video. You can skip number 2. Go ahead and do this, please. Okay, so we look here. Number 1, TQ. This arc is less than 180 degrees, so this is a minor arc. Let's just go ahead and classify first. QRT, so I trace it like this. QRT is this whole thing, so that must be major, bigger than 180. TQR, notice TR is the diameter, so TQR must be a semicircle, right? This is the center. QS, again, when you see 2 letters, you can assume it's minor, right? QS would just be from here to here, not the bigger way, the smaller way around. 2 letters, minor arc. TS, also minor arc. And then RST, if I trace that, RST also appears to be going, and endpoints are on the diameter here, right? Endpoints are on the diameter, RST, so this is also a semicircle. Okay, so our measures would be, this would be 180 degrees, this would be 180 degrees. Let's start over. TQ, so this is 120. Remember, our central angle is congruent, so this is also 120 degrees. QRT, QRT would be this guy, QRT. So again, what you can do is use the arc addition postulate. This arc plus this arc must be 360. So I could take 360 and subtract out 120. So this would be 360 minus 120, which equals 240. 240 degrees for QRT. Okay? We already got this as 180. QS, let's see, this, well, we already know the whole thing is 240. If this is 80, that means this piece here, TS, is 80. So let me just go ahead and write that. TS is 80 degrees. Right? So the whole final piece here, so QS from here to here, I could find by taking 240, which was this guy, minus this 80 right here. And that would give me 160. Okay? There's another way to do it, though. If you look, actually, no, yeah, you can't do that. Never mind. I was going to say vertical angles, but these aren't vertical angles, so never mind. This would be the best way to do it. Okay, let's flip over to the next page. Tell what these are congruent. So again, pause the video. We talked about congruent arcs mean they're the same measure and they're either from the same circle or congruent circles. Go ahead and just say yes or no and explain. And then once you're done with that, go ahead and finish this and you can check your answers. So just pause for a couple minutes, fill these out, 4, 5, and 6, and then unpause. Okay, right back at it. This is our red arc here. This is our red arc here. This is our red arc here, and this is our red arc here. So first, let's check the measure. Right, this is 145. This is 145, right, because the central angle is congruent. This is 120, and this is 120. Okay, so if I look here, these have the same measure, and the key is these circles are exactly the same size. We don't know how big they are, but because the radius is congruent, whatever it is, they're the same, so we can say yes. Right, they have the same measure, and AB, arc AB and arc CD are from congruent circles. So they're the same fraction of the same sized circle. Whereas these guys, if you look, this is the same fraction. They're both like 1/3 of the circle, right? 120 out of 360. But this is a bigger circle. So this cannot be the same length as this. So we can say no. They're the same measure, right? They're both 120 degrees, but MN is from a larger circle, right? Because the radius is larger than arc PQ. Okay? And then to finish off, find the measure of each arc. Arc BC is 32 degrees. BD, by the arc addition postulate, would be 32 plus 58, right? So, whoops, 32 plus 58. Get that focused again. So that would give me 90. Okay, arc ABC. So ABC, if I look here, again, I'm going through here, I'm going through the diameter, so that's 180 degrees. And finally, AB, when I see that, 2 letters just means a minor arc. 2 letters means minor arc. So I just take 180 by the arc addition postulate minus 32 degrees, right? Subtract out this piece, and I'm going to get 148 for this AB. Okay, that's it. Go ahead and start your homework.